Hi, again in this video we want to solve a problem with exactly Newton's sum. We've solved many problems of Stanford math tournament and now with Newton's sum, and now we want to solve this Harvard MIT math tournament again with Newton's sum. So why we love, you can also solve this with basic methods, but why we want to solve this with Newton's method? Because if you learn with Newton's sum, then you can solve harder problems. In some problems, you have to use Newton's sum. So it's important to get good at this general idea. It's so much useful because this idea is so much general also in Stanford problems, in American Math Olympiad, in Hong Kong 2022. There was one problem you had to use Newton's sum. So let's start. This video is useful for basic level student and also professional level math solver. Why? Because I've explained my description, timestamps or time codes. First part, quadratic function, I explained completely. So if you know that, you can use my description to pass part 1 and go to part 2. If you also know Newton's sum from my previous video, we can pass that and go straight forward to part 3, solving the problem. Okay, so let's start quadratic function. Quadratic function is, for example, ax squared plus bx plus c equal to 0. And we know, okay, if it has a root alpha and beta, you can write it x minus alpha minus beta, because here the leading coefficient, we say the coefficient of x squared in quadratic function, leading coefficient, you can write a. So these two equations are equal, these two terms are equal. So if we consider coefficient of x, left side will be b, right side will be what? Negative alpha x, negative alpha, negative beta x, negative beta. So we can conclude, if we divide both sides by a, b over a equal to negative alpha, negative beta. So we can say alpha plus beta, sum of the roots, equal, negate both sides, negative b over a. Now we want to find product of roots. For product of roots, consider the constant term in both sides, c equal to a negative alpha, negative beta. Okay, so if we consider that negative alpha, negative beta, so it will be c equal to a alpha beta, because we have two negatives, they will be cancelled. So alpha beta, if we divide both sides by a, c over a. So we found two important things, negative b over a, c over a. Now, sometimes, for example, some of the roots are, let's say, 6 and product of roots equal to 5. Someone says, okay, find a quadratic function that the roots are alpha beta. Here it's easy because integers, but I want to show you a way that also useful for real numbers, for anything, also complex numbers. So you say what? You say, okay, x squared minus, so here you say what? You say, okay, I know sum of the roots is negative b over a. So if you consider x squared, and a is 1 in this case. So alpha plus beta here will be what? Will be negative b. And here alpha beta product of roots, because a is 1, will be c. So, okay, so x squared, sum of the roots, negative b. Okay, so if we want to write, you say, okay, it is for the case that you have bx plus c equal to 0. B is what? Negative of the sum of the roots. So here, if you want to apply that, you say, okay, alpha plus beta equal to 6 equal to negative b. So b here will be what? If you apply this, it will be negative 6x. And c is what? Product of roots. Product of root here is 5 equal to 0. So if I consider this one s sum and this one product, you can say always, it's general for all sum and all product, x squared minus sx and plus what? Like here, we had 6, we've written negative 6. Here you say, okay, minus sx and 5 product plus p equal to 0. It is so much important. Then when you have, and we want to use this idea in the following problem. You say if the sum of roots equal to, and let me call this one star in part 1, if you know sum of roots is what and product of root is p, so these alpha beta are roots of what equation? What quadratic function? X squared minus sx plus p, which s is sum of the roots and p product of roots. Okay, so let's go to part 2. Okay, now I want to explain for you Newton's sum. It is correct for polynomial with any degree n, that n is positive integer. But here I want to use it only for quadratic functions, so I explain only for quadratic function. But if you had any question about general form, feel free to send message to my WhatsApp number in the description. So let's write. For example, suppose we have ax squared plus bx plus c equal to 0. So I define what? I define, okay, the first part. S0 is what? X0 plus Y0. It is what? 1 plus, X0 plus Y0, because we have XY, let me write it, alpha 0 plus beta 0. Alpha, beta are roots here. So we can say it is AX, you can also write it AX minus alpha, X minus beta. So it is what? 1 plus 1 equal to 2, S0. S1 is what? Alpha plus beta is sum of the roots is what? You can say here from part 1, we know sum of the roots will be negative b over a. If you want to find S2 from the coefficients, so you do what? Let me explain this. It is a little better I explain with what? With variables. For example, let me also consider a is 1 because you can divide both sides by a. So if I consider C, let me erase. I want to write answers. So for example, I say it is 5, or let me write it is 2, it is 3. General form. Now I can say what? Alpha plus beta is what? Yes, it has integer roots. You can check, but I want, it is just example to understand Newton's sum better. S1 alpha plus beta. From part 1, we said it is negative b over a. It will be negative 2 here. Okay, so it is not important that this equation has integer solutions, real solutions, or complex solution. It's general. So if you want to find s squared, s2 alpha squared plus b squared, yes, you can use the formula, many formula, but I want to show you Newton's sum. And it's so much important because, for example, if the roots are 4, we have 4 roots, and instead of S2 you want to find S4, alpha 4 plus beta 4, so it is so much hard to solve with other ideas, but in Newton's sum it's so much easy. So I say our equation is this: alpha beta are roots, alpha squared plus 2 alpha plus 3 equal to 0, beta squared, because alpha beta are roots, we can write like this. And then we can say what? Alpha squared plus beta squared plus 2 alpha plus beta plus 3. You can say 1 plus 1. Or you can say it is S0, and we know it is 0. It is S1. It is S2. So that's great. We found S2 plus 2S1 plus 3S0 equal to 0. If we consider this equation, let me copy and paste here. Look, the coefficients are exactly the same. X squared here, the coefficient is 1, here 2, here 3. Also, you can write for S3 all other things. So let's find at first S2. S2 is what? If we take all things except S2 to right hand side, negative 2S2 minus 3S0. S1 is what here? S1 is negative 2. If we replace, it will be negative 2 minus 3S0 minus 3 times 2 will be 4 minus 6, negative 2. So S2 will be negative 2. Similarly, we can write it for S3. If I explain for S3, you will understand for all terms. So I say what? X squared here. Let's use these two things. Because I want to reach S3, alpha cube plus beta cube. Can you guess I should multiply the first equation by what? Yes, alpha to reach alpha cube. And second equation by what? Yes, beta cube. So it will be alpha cube plus 2 alpha squared plus 3 alpha equal to 0, and beta cubed plus 2 beta squared plus 3 beta equal to 0. If we add these terms, alpha cubed plus beta cubed, S3 by the definition, the second column 2S3 if we factor from 2, and third one 3S1 equals 0. So look, if you pay attention to this one and this one, they are exactly the same. So we can similarly write S4 if you multiply the first equation and second equation by alpha squared beta squared, minus 2s3 plus 3s1 s2 equal to 0. You can write all of them. And then here you know s2 is what, s1 is what, you can easily find s3. So we can generalize this and say sk plus 2sk minus 1 plus 3sk minus 2 equal to 0 for k at least 2. For what equation? Our main equation was s2 plus 2x plus 3 equal to 0. So here, if you know the coefficient of your quadratic function, you only write sk plus it is correct for all quadratic function. Also, similarly, you can generalize this idea for degree greater than 2. So now you're ready to solve the problem. Okay, now we want to solve this problem. We want to create a polynomial that the degree is 2 and the roots are x, y, are roots. In part 1, I said exactly the polynomial is what? W squared minus SW plus P equal to 0, where S is x plus y. We've reached exactly this polynomial. For in part 1, if you don't know how we can write this, go and read part 1. You can use timestamps or time codes in description. S equal to x plus y, P equal to xy. We know x plus y from assumption of the problem equal to 2. So we can say W squared minus 2W plus product. Product is what? Product is x, y, or you can write this one. So here we know this, and from part what? From part 2, by Newton's sum, at first S0 is what? X0 plus Y0, the roots is 2 always, S1 is x plus y equal to 2. And in part 1, we said from assumption S1. In part 1, we said, okay, sk minus 2sk minus 1 plus psk minus 2 equal to 0. So, and for k greater than equal what? We said for k greater than equal 2. So sk equal to 2, sk minus 1 minus p sk minus 2 for k again greater than equal to. So we want to reach, right? S2 is what? S3 is what? S4 is what? And at the end, we want to reach S5 because in here we have S5. Okay, so let's solve the rest of that. You can solve many other problems. By this idea, you can go to my playlist, Harvard, MIT, Math, Stanford tournament. In that playlist, you can see many problems of Stanford's and other things. Also, many of them, you can use them and solve them by Newton's sum. You can see the picture of Newton's and understand that those problems can be solved by Newton's sum. So let's find S2. S2 here will be what? 2S1 minus PS0. S1 is what? S1 is here 2 we've calculated, look, we've calculated this. 4, S0 also is 2 minus 2p. So I write 4 minus 2p. Now I want to find S3. It will be what? 2S2 minus PS1. S2 is what? 4 minus 2p here. And minus PS1. S1 is 2, so it will be minus 2p, and it will be 8 minus 4p minus 2p minus 6p, 8 minus 6p. So let me erase them. Now I want similarly find S4. S4 is 2S3. 2S3 will be minus PS2. So if I replace S3 here, 8 minus 6p minus PS2, I have here 4 minus 2p. It will be what? 16 minus 12p minus 4p plus 2p squared. So if I write from p squared, 2p squared minus 16p plus 16. Okay, so let me write it here. 2p squared minus 16p plus 16. So one case is left as 5. Okay, if I want to calculate S5, it will be 2S4 minus PS3. So if I replace S4 here with 2p squared minus 16p plus 16 and replace minus PS3, S3 from here, 8 minus 6p. So if I calculate this, it will be what? 2 times 4p squared minus 32p plus 32 minus 8p plus 6p squared. So if I want to write 6p squared plus 4p squared, 10p squared, and negative 32p, negative 8p, negative 40p, and plus 32. Okay, now we use S5 and also S5 from assumption of the problem. It will be what? 10p squared minus 40p plus 32 equal to 82. So if I take 82 to the left hand side, then it will be what? 32 minus, or if you subtract 82 from both sides, it will be 32 minus 82. It will be negative 50 equal to 0. We can divide both sides by 10. Then it will be p squared. So here we've subtracted 82 from both sides. Divide by 10. P squared minus 4p minus 5 equal to 0. Now, let's see. Can we factorize this? Yes. P. We should write what here? Yes, negative 5 plus 1. Okay, so p will be what? Will be negative 1 and p will be 5. The problem says s is what? Sum of the roots equal to 2. So we should check two cases. The first case, case 1. X plus y, which is s, equal to 2 and xy equal to negative 1. So here, if I replace y with negative 1 over x and replace it here, it will be negative 1 over x plus negative 1 over x, or x minus negative x equals minus 1 over x equal to 2. And if you multiply by x both sides, it will be x squared minus 1 equal to 2x. So x squared minus 2x minus 1 equal to 0. So x equal to what? Negative 2 plus minus b squared, 2 squared, negative 2 squared, minus 4ac minus 4, this, negative 1. It will be 2 squared 4, minus 4ac, it will be minus here, we have plus 4, it will be 8 over 2a. So it will be negative 2 plus minus 2 root 2 over 2, and it will be negative 1 plus minus root 2. Sorry, here, because we have negative 2, I should write positive here, positive, so it will be positive 1 plus minus root 2. So x and y are symmetric, so you can say x and y, in one case, x is 1 plus root 2, y is 1 minus root 2, and the product will be negative 1, and sum will be 2, or 1 minus root 2, 1 plus root 2, you can switch. Now, let's consider case 2. X plus y sum is 2. In this case, product here, let's check 5. So again, I consider y equal 5 over x and be replacing first equation. It will be x plus 5 over x equal to 2. And if you multiply by x, then it will be what? X squared plus 5 equal to 2x. If we take all things to one side, x squared minus 2x plus 5 equal to 0. If we calculate discriminant here, the thing inside the square root. Let me write the formula if you don't know that. Okay, here, if you have this quadratic function, x is this quadratic formula, you can use this. You should memorize it. It's so much important. Here, d is what? B squared, b is negative 2. Negative 2 squared minus 4ac, which will be a is 1. And c5, it will be 4 minus 20, which will be negative 16. And the thing inside the square root is negative. So that's contradiction. Why? Because x and y are real from assumption of the problem. So we have only these two answers. So if you've learned something new, please don't forget to like and subscribe and turn on notification for having next videos. In algebraic problem for Stanford, MIT, for Olympiad, there are some rules like Newton's, some general things, around 20 important rules. If you don't know them and if you want to learn them, feel free to send message to my WhatsApp number in the description. And also, if you have any question, you can comment below. Thanks, and you can use the playlist on my screen to go and solve Harvard, MIT, Stanford problems, and many other things. Thanks for watching my videos and for your support. Bye.